we have a boy seated that is standing on this step. This is the total height of the steps. So work done in climbing a number of steps. The work done is the weight of the boy times the height of the whole step. So we say h is equals to the height of one step times the number of steps in this case. So we can write our work done equals to mgh. In case, let's say the height of one of the steps is about 10 centimeter, and we have how many steps here? We have 1 step, 2, 3, 4. That means 10 centimeter times 4 is going to give us 40 centimeters. So, and that's the total height of the steps that we are going to use. Now let's quickly look at force displacement graph. So we're going to deal with two. The force displacement graph. So we are going to look at two. We have the force on the vertical axis and the displacement on the horizontal axis. So for work done, let's say this is the displacement. The area under the force displacement graph is the work done. And what's the area of this? That's the area is equal to area of rectangle of the rectangle. So that's so we can say this is OO, and this is our F here, and this is our distance S. So that's the distance in meters, the displacement in meters, the force in newtons. An example of this is push or pull. Now, this is when the force is constant. So for force, we can say this is force when force is constant. Force is constant throughout the distance moved. But in another case, the force is increasing. The force varies. Force varies with distance. Then we can draw this. Say our force here, force, and our distance or displacement here in meters. The force varies. That means it's increasing. And in this case, if we trace this, the area under this graph represents our work done. And what is the area under the graph? So the work done here is equal to area of the triangle. Let's call this 0. Let's call this E. So we're going to use E here. It's also a distance. And this, we can say this distance is extension. So, and we have the force there. What we're going to have here, the work done in this type of diagram is area of the rectangle. So we have half the height of FE, and this is half of FE. This is the work done in stretching an elastic material, let's say a catapult or a spring. So this is the work done of FE. So we can be given so many questions on this. Make sure you subscribe to the channel. We'll see.